So these are non-real complex solutions, which means we're going to be getting imaginary numbers for our answer. So we have two types here. We're going to be solving ones with one visible x. You want to look at it as if you were a 5-year-old, and you see this if you were asked as a 5-year-old, how many x's do you see? You would say 1. We already know there's a square there, but you would see 1, and you'd see 1, 2. And so there's two different methods. If you have one visible x like this as a square, we solve using the square root property. And if you have 2, then we use quadratic formula. So let's start with the square root property. So to solve this, we already know we're going to have to use its inverse. So that's a square root. But as you introduce the square root, we know that we're going to get a plus or a minus here because we're going to have a positive or a negative. So like if you had negative 3 squared, you would get 9. And 3 squared is equal to 9. So if we had x squared equals 9, we know that we would have x equals negative 3 and positive 3 because those are our two solutions. And so again, we write this as plus or minus 3. So when you take that square root, you have to put a plus or minus in front. It works the same no matter what. So the only difference now is we're going to deal with an imaginary here. So if you remember, every time you have that I, you want to cross it off and put an I in front. So now we have this gigantic thing that we just have to simplify. So we have plus or minus, and I know you see square root of 144 is 12, and you can write it, but I'm going to take this a little bit slower, like that. So square root of 144 is 12. And when you write that, you always want to put the 12 first, and then the imaginary. So doing these problems, they're not too bad. They're actually fairly quick and nice, but it's all about form and how you write them. That's why we have so many examples on here. All right, let's try another. So we get rid of the square root, and we put plus or minus in there. We put the red back on there. All right. And then you cross off that and put an I in front. And then we rewrite. So x equals, because remember those cancel, plus or minus, and then I, square root of 12. So on this one, the 12 is not a perfect square, so we do have to simplify it. So we know it's 2 and 6, 2 and 3, so we have a pair of 2's. So what two numbers are being multiplied by themselves? 2. So we end up with 2 square root of 3. So square root of 12 is 2 radical 3. So it looks like this. And so here is the form again. That I, whenever we have it, is always at the end, or it's attached to the radical. You don't want to put it at the end, at the back, because it's bad form. If you say 2 radical 3i, it looks like it's inside. And then even if you do this, it looks like it's inside. We always write the radical at the end. And you don't want to write I 2 radical 3. That just looks weird. So you have an option. You write 2 radical 3i, or you place the I in between the 2 and the radical 3. This is just for form. Obviously, they're all correct no matter how you write them, but it's all about form. By placing the imaginary in between, and the radical here, we know that only thing in the radical is 3. It's an imaginary, and it's a 2. So it's all about form. So you either write that, or you write that. Your choice. All right, let's do one more. So on this one, if you notice, there's a negative 3 in front. And on all of these problems, you have to isolate the variable before you're allowed to apply the operation. So if we're going to get rid of the square, we have to get rid of the negative 3 first. And so this gives us x squared equals negative 16. Now you can apply the square root. So you have to isolate first. Plus or minus. And so I know you guys are probably good at this now, so let's do this. We know that's an I, so it's going to be plus or minus. That's a 4, and that's an I. So plus or minus 4i. And that's your answer. So these are the three things you're going to run into. It's going to be a nice perfect square that simplifies, or an irrational, so you would do this, or there's going to be a number in front. And now, if there's something being added, you've got to add that over as well. Okay, let's try these now. So now, if you notice, this is fully isolated. There is nothing outside of that parenthesis that is being added or subtracted or multiplied or divided. So when I apply it, I have direct contact to the square root. Don't write this, but now if there was a number in front, if I apply my square root, you see I don't have direct contact. So like, think about this like a little trebuchet, and I'm rolling up my trebuchet to break open the castle walls. If outside I've got some archers and some soldiers, if I roll up that trebuchet, the archers are going to just shoot all the people trying to roll up the trebuchet, and the soldiers will come and just knock the trebuchet down. So the first thing I have to do before I roll my trebuchet is get rid of the 5 and get rid of the 3 so that I have my nice isolated expression. And so now when I roll up my trebuchet, there's no 3s or 5s to kill up my trebuchet. It'll just completely knock down the wall. So you've got to have a process going. We have to get rid of that -3 first before I can attack the square. Okay, so the whole idea here is our castle walls, everything's inside, so I can roll up my trebuchet, kill off the square, do the same to the other side, put my plus or minus, and everything's good to go. So we have 6x minus 1 equals plus or minus, and then we now know that is 2i, because that becomes an imaginary. And if you notice, I'm always putting the I in front of the radical, not behind, because you don't want a square root of I here. All right, the rest is just form. So we're going to have to solve for this equation. We're going to have to get rid of the -1, and we're going to have to get rid of the 6. So we just go in order like a normal equation. Plus 1, plus 1. And when you write it, you always place that right in front, because what is this called? Plus or minus, not positive or negative. We call it plus or minus for a reason. So this number in front is going to say 1 plus or minus 2i. That's what we want. We want this to say plus or minus, not positive or negative. You've noticed that. It's really not plus or minus up here. It's positive or negative. And so this is the reason why. And then the last step is nice and quick. You just have to divide by 6. And we end up with x equals 1 plus or minus 2i over 6. And that is our answer. Now, you can also split this up into x equals 1 over 6 plus or minus 2 over 6i, and then keep going and say this is x equals 1 over 6 plus 2i, and x equals 1 over 6 minus 2i. It's your choice on any of these are correct answers. So they're just all different forms, but it's always going to have that number, plus or minus, imaginary, divided by 6. Any 3 forms is fine. All right, let's try the next one. The next one's going to have is our last type, and so we did one with a nice perfect square. So now when I take my square root, I'm going to get 4m minus 7 equals, and it's not a perfect square. But we do know we have plus or minus. So square root of 27, let's cross that off and put the I. That's 3 and 9. There's our perfect square, 3 and 3. So we have a pair of 3's. So that's 3 square root of 3. And then we add 7. And we get 4m equals 7 plus or minus 3 square root of 3. So just like before, we put that 7 right in front. Divide by 4. And there's our answer. And I'm going to leave it in this form. Again, you can split it into those other 2 if you'd like as well. All right, our last one now is quadratic formula. So these are just going to have imaginary solutions here. So our A is 4, our B, and this is the reason. If you have a B, you're not using square root property. If there's no B or your B is 0, square root property. So x equals the negative boy couldn't decide, go to the radical party, or the square bouncer, remove 4 alcoholic cans, and it was all over at 2 a.m. All right, so let's plug this in. Negative and then 5 plus or minus. See, those are plus or minus just like before. And then 5 squared minus 4 times 5. All over 2 times 4. Now, again, that radical is the thing that is the hardest part of these problems. So that's why we always still write it off to the side. So 5 squared is 25, and then it's minus, and then 20 times 5 is 100. Or sorry, 16 times 5 is 80. So it's 25 minus, because there's no more negatives, and then 20 times 4 is 80, or 16 times 5, but it's 80. So subtracting this, we get 55. And then if you break the 55, you get 5 and 11. So there are no pairs, so we know that we are done there. So now we just write it, plus or minus. Forgot the negative. The square root of a negative 55, that would be I rad 55. Remember, that's our I. So it's I rad 55. Always put it in front. All over 8. And there we go. And so you can see it's the same form because these are all quadratics. We're getting the same type of answer. You can see it's that number plus or minus the imaginary over 6. If there's no numbers inside, we're just getting that imaginary part. So this is why they call it complex solutions. So you're going to get pure imaginary answers, or you're going to get answers that are part imaginary, part. You can see I forgot my I right here. Thank God I went back over this, huh? 3I rad 3. And see, if you didn't finish the video, you would have gone, oh my God, the problem's wrong. But no, we went back and fixed it. There was an imaginary here. And so you always have to go back and check them. Everybody makes mistakes, even us veterans who've been doing this for a long time. All right, but that is it. Those are your complex solutions.